So how can we obtain a direct current from alternating current? This is done by using a rectifier. The rectifier, which is a device for converting AC to DC, is installed on the rear end frame of the alternator. The circuit diagram shows that it contains several diodes, which allow current to flow in one direction only. Before we continue, let's discuss the principle of rectification based on a simplified circuit diagram. When terminal A of the alternator is positive and terminal B negative, current flows like this. However, when the polarity of the alternator reverses, the current can't flow in the opposite direction because of the diodes. This means that current flows only in one direction through the load. That is, direct current is produced. This is what we mean by rectification. The alternator produces three-phase alternating current, so the direct current after rectification is as shown. This is what a rectifier looks like. One more problem remains, however. The rotation of the engine varies according to the vehicle speed, and the faster the rotation of the engine, the more current is generated. The electrical and electronic components of automobiles, however, can only operate with voltages in certain ranges. So, excessively high voltages can damage the components or overcharge the battery. To avoid this, the voltage that is generated by the alternator must be kept within a certain range. Let's look at the regulator which controls the voltage generated by the alternator. The voltage regulator is installed on the alternator beside the rectifier. Its internal construction is as shown. It consists of a hybrid IC having a built-in monolithic integrated circuit, transistors, and so on. Please note that this type of regulator cannot actually be taken apart. Now, we will explain how the voltage regulator works. First, battery voltage is applied to the rotor coil of the alternator. Then, the alternator rotation speed is gradually increased. Let's measure the voltage generated at terminal B, which is the alternator output terminal. As you can see, the voltage increases steadily. If this continues, the electrical components will be damaged and the battery will be overcharged. As we explained when we talked about induced current, there are three ways for varying the generated current: the speed at which the magnetic field is cut, the number of coil windings, and the strength of the magnetic field. If one of these is changed, the generated current changes also. With the alternator, however, the speed at which the coil cuts across the lines of magnetic force depends on the rotational speed of the engine. Furthermore, since the number of windings is of course fixed, the voltage can only be controlled by changing the strength of the magnetic field. We now put a variable resistor between the rotor coil and the battery. When the rotation of the alternator decreases, we can increase the current to the rotor coil by reducing the resistance of the variable resistor. This will strengthen the magnetic field of the rotor. On the other hand, When the rotation of the alternator increases, we can decrease the current to the rotor coil by raising the resistance. This weakens the magnetic field of the rotor. As you can see, this time the generated voltage did not increase. In short, the regulator functions like a variable resistor. The regulator controls the current in the rotor coil according to the engine speed, thereby maintaining the alternator output voltage within a predetermined range.